All right, Scott.
Yes.
This guy is amazing. When I have a problem, this is one of the guys I go to say, "What the heck is going on here?"
I'm amazing because I don't charge you.
You are amazing, man. So amazing. You know, then every once in a while, Sierra sends me a bill. And I'm like, wow, dang it, that wasn't free. Beautiful. I pulled my first SAP test out of the fact of wanting to know what the hell was going on because I'm not good enough at reading a plant and knowing. I'm not experienced enough at knowing the plant as well and seeing some of these deficiencies. And I had people tell me that the fall fade was a myth. And I was like, really? So I decided to implement some SAP testing, and I implemented some corrective foliar spraying, and only knowing about 3% of the knowledge necessary to fix these issues, I was able to really improve my own quality and my own experience because I had data I didn't have before. I think that's the powerful thing about testing and using these tools is you going to get data you did not have before. So I'm going to stop talking here and let the man explain all this good stuff.
All right, so I'm Scott Wall. I don't think we need to do any more introduction there. Let me get this figured out. There we go. So, plant sap analysis. I don't know how many of you guys have used it before. You may have used a lot more dry tissue. Everybody is enamored with dry tissue, which is not surprising because we have used it for decades. And it's well known. So we keep using it over and over and over again. But I'm going to show you an alternative. Plant sap data. What is it? It's the nutrient concentrations in ppm, and it's the metabolic parameters that are going on inside of the plant at the time that you take the sample. All right? It's the sap that we remove from the samples, and we're going to look at the data relative to what's in the new growth at the time that you take it, relative to what's in the old growth at the time that you take those samples. So you're taking a pair of samples, all right? New growth, usually in cannabis, we're looking at about the 5th node down. You want a sample that's big enough for you to give a high five to you. If it's not big enough, it's not old enough, it's not fully photosynthesizing, it's taking nutrition from the plant, it's not producing the metabolites and stuff, okay? So you want to make sure you're far enough down on the plant. And then the oldest leaf is the source. So you want to come up from the bottom, you still want a viable leaf, and we're going to sap the nutrients out of both of those pairs, and we're going to compare it, okay? It provides the insight into the nutrient uptake at the time that you take it. It's going to show you deficiencies before you ever see it in the plant. It's going to show you excesses. It's going to show you imbalances. It's going to show you simple metabolic health status of your grow at the time that you take it. So, I'm really glad that I got Bryant down here because we get to have a great conversation this week while we're here. What is SAP data from Newage? Okay, when we're talking about the SAP data that you're going to get from us, we're working to make sure that we're giving you the data from the vascular tissue. This is the sap, the fluids that are going to come out of the vascular tissue, the xylem and the phloem of the leaf, the petiole and the leaf structure. Okay, so in this particular footage, it's this bundle of tissue right here. Now, we work really hard to make sure that we're not getting into all the other cells, into the vacuoles there. So that's critical for our process. That's what our data is based off of. That's what our target ranges are based off of. Okay? What's that data that is not that you get from Newage is all the other fluids that are in the tissue. Okay, it's not the vacuoles, it's not in the mesophilic cells, it's not in the endoderic cells. There are other labs, both in the United States and globally, that though I cannot tell you exactly what their processes are, we can duplicate their data or similar data to what they do by doing a process that is more along the lines of what we call leaf extract. Okay? And what that does is that we take the leaves and we masticate it, or we crush the tissue up into very fine particles. We put that into a 50 ml test tube, and we add lab DI water. And now we're extracting the nutrients out of that masticated tissue. So all these cells are now ruptured. Okay, we've broken them up. And this is very similar to how we used to do scientific extractions for contaminants in soil, is that we expose the soil to solvents. In environmental testing, we wanted a very aggressive solvent. But water is a solvent as well. And in this situation, it's the simplest solvent that we can use. And so we expose the masticated tissue, and in this case, we only need about 5 grams to really do this, to 50 mLs of DI water, and we extract the nutrients out. And when we do this process, we can match the concentrations and the relative abundance ratios very closely to a lot of different labs. And that's why we're talking nowadays about, even though we have multiple entities out there that want to talk about being plant sap, are we talking about the same thing? Okay, it's like saying we're doing a soil test. But if you don't specify what you're testing and how you're testing the soil, you're talking about different things, right? You don't do it, if you say soil test, but you do a saturated paste, but the other lab does a Malik 3, or somebody else does a total assay, totally 3 different looks at the same matrix. And that's kind of what we're talking about here. So, whether or not you do it our way, or you do it a different lab's way, like with a leaf extract, what we're looking at with our process is we're going to look at the xylem and the phloem. Okay? In the plants, we have 2 major pathways for nutrient uptake into the plant. Well, the only way that it really gets up into the plant is the xylem. Okay? This is a series of dead tube cells, basically, running from the root system up into the plant. Sap only moves in one direction, up. Okay? From that point, it's like mass rail. This is bulk movement of metabolites, solutes, from basically the cytosol in the root system up into the plant. Okay? This is the main passageway for all the bulk solutes that the plant is taking up. Once it's up into the plant, now the leaves start producing secondary metabolites and there's sugars and all the photosynthesis that's going on, and the phloem takes over. Okay? And now phloem is like taking intermodal boxes off the rail and putting it on trucks, and now you've got the whole interstate trucking system that can move this stuff from factories to warehouses to retail. That's what's going on with the phloem system. Okay? And in phloem, now we're moving nutrients and sugars and secondary metabolites in our case with cannabis, we're talking about terpenes, we're talking about organic acids and all these other things that are traveling in this phloem from the leaves to the buds to the roots, partitioning between the new tissue and old tissue, and that is very important in what we're going to talk about with sap analysis. Because the power of sap analysis really comes from the ability to compare mobile nutrient concentrations between the new and the old. And this is where you come to find out that the most knowledgeable consultant on your crop's nutritional status is not sitting in the chair next to you at your console or on a Teams meeting. It's the plant sitting on the bench in your grow. Okay? And when you start to learn how to read nutritional partitioning and in the source and the sinks in your grow, you will start to learn the language of your plants. And this is cannabis, it's everything. You will start to understand whether your plant is taking up more nutrient than it needs, or it's in excess, it's not taking up enough, and therefore it's stripping nutrients from the old tissue at that source and stripping it out of that to send to critical growth points in the new tissue for new growth, or sending it to the flower because that becomes a primary sink, or it's going down to the roots, which we don't really sap, but we've taken a look at that. Dry tissue. So dry tissue is predominantly done in the United States and really across the world. Okay, why? Because it's been done for decades and we've figured it all out. We pretty much know, hey, if there's this much nutrition in the dry tissue and the structure, this is how we correspond with nutrient. It doesn't mean it's a tried and true method. But what it does is it takes a look at all the nutrients that have gone into the construction of those leaves from the moment it was conceived until the time that you take it out. Okay? It's great for mass balancing. It's great for telling us what's been taken up over time, but it's not all that great for what's going on in the moment that you take that leaf. Okay? Because it's looking at everything that's gone into the brick and mortar, and what's necessarily in the brick and mortar is not necessarily available for your crow to continue development from that moment on. A lot of that is committed, and it can't access those bits of nutrition. Sap is liquid. Dry tissue is going to get into that brick and mortar. So sap analysis looks at current nutrient uptake, unincorporated, and repartitioning nutrients. Dry tissue is everything. All the brick and mortar is what's in the vascular tissue as well. The only thing that they're removing is moisture. Okay? And then it takes a look at everything else. Sap analysis is looking at, in our case, is looking at xylem and phloem from the leaf and the petiole. It's going to look at have its best power with mobile nutrients. So, phosphorus, chloride, potassium, magnesium, all the nitrogen forms. I will argue that sulfur does. Others will argue that sulfur does not. Sulfur as an ion is not very mobile. Sulfur as an organic molecule, particularly with nitrogen, is highly mobile in the plant. At least from the data that we've seen, supports it quite a bit. Early detection of deficiencies, well before you'll ever see symptoms in the plant. Provides insight into metabolic parameters of photosynthesis that you won't get with dry tissue. Dry tissue is typically only done on newer growth, therefore you're only seeing one side of the picture. It's only the new side. It's not new versus old. You can use it in pairs. It does have more strength if you do it that way. It's usually late in detecting deficiencies and excesses, usually 4 to 5 weeks. Its best use is probably for mass balancing. This is a paper that came out of the University of Guelph. It's specifically, the researchers here imposed single nutrient deficiencies and on cannabis through the entire growth from veg all the way through to flower harvest on about 10 different nutrients. They saw the symptomology, the symptoms develop. They could identify it. They took what their conclusions were is that The imbalances were critically important to the overall yield of the plants, so that when you did get these imbalances, it was detrimental to the overall success of yield. The individual nutrient deficiencies showed common symptomology that we see in agriculture on other species, but that there were other symptomologies that seemed atypical to other agriculture, and that they attributed only to cannabis. Okay. Lastly, though, what they used dry tissue for their analysis. What they determined was that dry tissue failed to correlate with the symptomology. They did not detect in their analysis the symptoms that were plainly obvious and that they knew, based on their induced deficiencies, were present. So here we have an example where there was a known deficiency because they caused it. The symptoms were clearly present, but the testing by that method did not detect it based on the sufficiency ranges that are established for the cannabis facility. So, SAP analysis and how do we apply it? Some of this we'll get into more in the workshop today at 3:30. But you're going to collect a stack of sap of leaves. No matter what your crop is, this happens to be cannabis. For cannabis, it's about 50 to 60 leaves. That's a significant sample size. It's more than what you would need for dry tissue. This is going to get sent to the lab overnight. You're going to keep it from dehydrating. You're going to put it in Ziploc bags, express all the air out so that we keep it in stasis. Keep it cool. Keep it without having oxygen available to it, because even though it's separated from the plant, it's not dead. It's still respiring. Okay? Once we get it at the lab, if within 24 hours, we're going to sap it. That is sap from cannabis, mostly some of our purple strains and varieties. Once it's sapped, it's going to go through 5 different analytical platforms in the laboratory. We're going to process it into basically a flat file database, which is available to every grower that participates with us. And then you're going to get a PDF report with a header and so on that looks pretty much like this. Okay? And it's these relationships, the light color being the new data, the dark color being the old data. It's that comparison between the new and the old that gives you the power of what the plant's telling you. Okay? And for the nutrients that have the percentages on the far right-hand side, we've pre-calculated what the percent difference is between the new and the old. And so when the concentration in the new, so like this sulfur, is greater than the concentration in the old, no matter what I tell you it should be, the crop is telling you it wanted more, and it was failing to take up enough. Keep in mind, this does not tell you whether or not you're supplying enough. Does not mean that you didn't have enough sulfur in the soil or in your feed formula. This means that the crop is failing to take up this sulfur. Okay? In the phosphorus, where there's more in the old than there is in the new, that's telling you that the crop is more than satisfied with the phosphorus uptake it's currently receiving for its metabolic purposes in its growth stage that it's currently in. It's satisfied with this level. It is shunting all the other excess phosphorus that it's taking up into the old tissue for storage. It becomes the source. So when you talk about source and sink and sources in agriculture, this is what we're talking about. Your old tissue becomes the source. Your new growth, your flowers, and your roots become sinks. Those other sinks are going to take from this source area. Okay? This is great for mobile nutrients. Yes, sir.
Is that all parts per million you said earlier?
This is all in parts per million, and this is irrelevant to how much mass we had to sap to get the sap. Okay, this is all based on an ml of sap. Okay, so it has nothing to do with whether or not your plant's stunted or growing so fast that the leaves are twice the size that they should be. Right? It's separate from that. So there's no biasing one way or the other from that concept. Where you could get biasing, and this is an important fact sometimes, is in your EC. Okay? EC can be influenced by a couple of factors. Most of the time, it will be affected by an irrigation issue. Okay? If you're overwatering or you're undersupplying nutrients, that's two sides of the same coin, okay? You will have a low EC, okay? If you overwater, you dilute out the nutrients that the plant's going to take up extra water, you get a lower EC. If you go into a drought situation or you drought stress your plants or you apply, typically plants will not take up nutrients faster than they have to, but if you put them in a drought, they lose water, and so the EC will climb. Okay? So it's more of an indication for you as to whether or not you have an irrigation issue than anything else. Okay? We have a nice place where we want to see a balance. I have a concern usually if I see an EC at the top of the plant that's quite different than the EC at the bottom of the plant. That's usually telling me that we've got some kind of disconnect going on in the growth. Okay? Non-mobile nutrients. Non-mobile nutrients, as you heard this morning, your non-mobile nutrients are going to cause you deficiencies in the new growth. So what we really want to watch out for is where are our concentrations in new growth. The plant cannot go into the old tissue and grab those nutrients and pull them up. That's not a source for non-mobile. So for your calcium, which is critical for us in cannabis, because the trichomes are made up of almost entirely of calcium. Okay, you've got to get your calcium up. The only way to get calcium up into the plant is through transpiration. So you have to have water solution, because if you don't have good soil moisture and around the root zone, and you don't have calcium available, it can't get moved up into the plant. All right. So this is where you're going to get the power from. Yes, sir.
Could you go into any specifics on the certain calciums you need?
The certain calciums you need?
Yeah, like, I mean, it depends. Like all calciums aren't made equal. Like it all depends where it's derived from. You know, it's like because there's let's just say synthetic and organic. Like, yeah.
Well, keep in mind that now I may say things up here that I'm not an amendment guy. Okay, I'm the plant sap guy. So keep in mind that organic, whether you're organic or not, the plant doesn't take up organic. The plant takes up ions. So the organic amendments have to be converted biologically into ions to be taken up. Okay? So, yes, sir.
I'm curious, like if you're seeing a lack of calcium and maybe, conditions aren't, maybe you're oversaturated with water because you're in a wet garden space, so transpiration isn't happening the way you want it to. Foliar applications of calcium, is that like a thing that you can do to help correct and steer things the way you want if you're not getting the right condition for
there is a lot of there's a lot of work going on with foliar applied calcium in a lot of agriculture. It can be done. I think the fallacy that is being made or sold to a lot of folks in agriculture today with foliar applied calcium is that you keep in mind that calcium is immobile. Okay? Great. Foliar apply it, and once it's absorbed, that's where it's going to stay. it's not just because you foliar applied it does not mean that all of a sudden it became mobile. The xylem isn't going to take it someplace else. The phloem is not going to take it someplace else. So if you need it in fruit, it's not going to go from the leaf surface down into the fruit. So if you need it in tomatoes for blossom and rot, one, you've got to know when you have to get it into the tomato for blossom and rot, which is early in a very young tomato when the rapid cell development is going on, and you've got a heavy veg going on. Early spring is a critical time for blossom and rot because the calcium demand is so great that even if you're getting good transpiration up, the demand is huge. So even though you see blossom and rot when the tomato is developed farther along, the damage was caused earlier. So, like my concern is with my Amish growers. My Amish growers don't monitor their VPD, right? So early spring they get really hot days. They don't monitor the VPD, and the plants shut down. The stomata shut down. Well, no stomata opening, no transpiration, no calcium. Okay, so when I explained this to an Amish amendment guy, he said, "Oh, so when those conditions hit, what we should be doing is foliar spraying calcium onto the young green fruit." Okay, I'll tell you what. This coming year, you do that, and let's take a look at that. I don't know. Maybe it'll work. I'll be interested. I mean, like they were saying this morning, everything's an experiment. Give me a control and give me a test. I think that'll be interesting to find out. I don't know. So it could be. Yes, sir. No, we've done those trials. Particularly, my biggest concern with that was with clay sprays on citrus. We do a lot of citrus out of California and Florida, and they spray a clay foliar to shield the sun. And I was always worried about this, and other foliars as well. So we've done trials where we've washed leaves and sapped them. And we've sapped them with the foliar still applied, and we've seen no difference. The key here, when I showed you earlier how, we sap to get just the vascular fluids, okay? So we apply a linear pressure at a slow rate to express that sap out. It's never in a solution, okay? If we did the other test where we were doing a leaf extract, then you would have that problem. Yeah. I don't know how Nova does it. I don't know how Apical does it.
They do problems with residues from like magnesium.
Yeah.
So maybe
Then in my opinion, that is probably a likelihood. Given the fact that Nova has reduced their sample size over the last 5 years, the only way in my trialed experience, the only way I could possibly reduce my sample size is to come up with a method on how to get more sap out, and that the only way to do that is to break the tissue and do this extract system. I would love to learn how everybody else is doing it and we could share, but we won't share with one another yet. Not until it becomes a much more established science. And right now we're all protecting our IP, right? So as you keep building your data, this is what you get. So this is one of my grows. This is all watermelon sugar, and this is all new, old. And you can see where we can establish what's going on with their nutrients, and particularly their mobile nutrients. Okay, so I just happen to know that that this is chloride here in the front. So if I've got 3,800 and it's over 6,200, I've got an excess uptake in chloride. Okay, and I think that's too high for chloride, so I'm a little bit doubtful that I've got those columns in the right order there. But that's what you're going to look for in your relationships, okay? And you track these. So if date-wise, you can see the sample of dates here. You start tracking that. You put it in a trend line, and you match that to your management styles, okay? Now, the gentleman that was up here earlier says he doesn't defoliate enough. He always goes back in there and says, I could defoliate more, okay? Well, I'm going to tell you that when I grow, I don't defoliate because I pay too damn much money for all the nutrients that I put into cannabis. And if I take off the old tissue, I take out the sinks. Well, that's where my potassium, my nitrogen, my phosphorus is. If I put in extra, it's all sitting in that tissue. So if I take it out, I'm throwing away money. And too many of us are losing money. So why do I want to take it away? And if it's because of IP, well then you better figure out how to fix IP instead of taking away the leaves from the plants for nutrients that you've already paid for that they're going to use when they get the bud swell. Doesn't make sense to me. So how and where should we apply SAP data? There's a lot of places where we can take this and put it into our management styles, okay? Nutrient uptake over time, trend lines to assess the effect and cause of abiotic alterations. We've all got these, whether we're doing living soil, whether we're doing CEA, whether we're doing greenhouse, you name it, we've got these issues going on. Feed formula shifts from veg to flour. We have one feed that we use in veg, and we got another we do in flour, and we make a shift like that the minute we move from one room to another, we say arbitrarily we're now going to put them in flour. And we make a shift like that, and all of a sudden, this is where we almost always see nutritional problems develop. And you don't realize how much trouble you're creating with that shift because you're changing the pH in the soil with that nutrient change and so on and so forth. There's a lot of different things going on there. And so we need to do a better job of monitoring what that transition phase needs to look like. And I'm guilty as anybody. I don't think we've developed a really good monitoring or a concept of where we need to go with transition feeding. Okay? And don't jump feeds around quite so much. Also, learn how to mix your own feeds instead of buying out of AB jugs. AB jugs are not a good thing. Variations in feeding profiles between strains. Most of your strains feed differently. All cannabis does not feed alike, and this is true across other crops as well. Some strains are very heavy feeders. Some strains are light feeders. You cannot feed them the same. If you've got a CEA, even Steve with his wonderful living soils, he gets a little bit more balance in there. But if you've got multiple strains in that room, they all have the same abiotic condition. They're not going to feed the same way with that one abiotic condition. So you've got to know why is this one showing symptoms and something else is burning. And you got to pick up on that, and that's what SAP analysis will help you with. And if you can start putting them into silos, heavy feeders, light feeders, you now know who to put in the same room together, right? And say, okay, that's got to be a different feed than those. It also comes in handy if you've got different ones that harvest at different times. So because now we're going to start growing exceptional weed instead of mediocre weed. PPFD, my buddies with FOS, I see Mike in the back there, we have been talking and working with this probably for over 2 years now. We've got these LEDs that can really push a lot of PPFD. Well, you can't run PPFD at 400 and think the plant's going to feed at the same rate as if you try to push it at 1400. It's not. It just doesn't. That's like trying to run a car with a bigger engine with the same fuel supply. It doesn't work. Okay? So you've got to know what that shift's going to look like. And not every strain, again, is going to take that increased PPFD. So you've got to be able to see when that engine starts crashing and figure that out through monitoring. Ventilation, microclimates, if you multi-tier, that climate in that room is not the same on the top tier as the bottom tier. So if you're sampling, don't sample and combine your samples. Sample the top tier, keep that separate from your bottom tier. Because the environment is different, keep those separate. Know what's going on in those different environments and identify it. Changes in staff. Doesn't matter what state you're in with legal cannabis. We are at a point now where people turn over in these facilities all the time. And when Joe gets let go and Steve gets pulled in from the defoliation crew and now he's in charge of fertigation, you better make sure you've got some kind of system that's monitoring your fertigation program. Otherwise, you could be 4 weeks, 5 weeks in, and everything's starting to go to shit. And then you've got to figure out why. And it's not always on the top of your head that it's Steve. It's, oh, maybe we got hop latent virus, or we've got this, or we've got something else. If you're monitoring with some kind of testing, and I prefer SAP analysis, you're going to have a monitor system to catch it before everything goes sideways. This is trend lining. The trend lining with percent deficiencies or excesses. So the zero line is running through here. If it's above the zero line, you're in excess. If it's below, you're in deficiency. Here we're looking at deficiencies, and here we're looking at GH blunts. These are the anions with total nitrogen. Here's the cations with total nitrogen. The interesting thing here, this is where we start talking about imbalances, okay? And when you get competing, like when we talk about the molar charts, where you get competing interactions with elements in the soil, well, these types of things happen in the plant. The plant wants to keep balance, okay? So if you get really high uptake in excess in one element, you can suppress the uptake of another element, all right? I like to talk about chloride a lot, okay? And the reason I talk about chloride is that nutrient providers don't tell us how much chloride is in the feeds that they're providing to us. So I consider it a hidden element, okay? Potassium is another one. In the commercial fertilizers that you buy, they're typically made for conventional agriculture. So they're made for filling out fruits and vegetables. We don't fill out a fruit and vegetable. We don't need that much potassium. And what happens is the plant takes up all this potassium, and now it's in excess, so much excess that it inhibits the uptake of magnesium and calcium, which we need critically in cannabis, okay? So keeping those balances and monitoring is really critical. Next slide. So this is anions in, this is in a GC4 strain, this is in purple haze. Same grow, and on this one cycle. The orange is sulfur, the dark blue is chloride, the gray is phosphorus, okay? So, as we had this large sulfur uptake, okay? And once that got pulled down, it opened up the door for the phosphorus to kind of pull up, okay? Here, the chloride is not the issue. And chloride is not bad. I think I've gotten, I talk negatively about chloride because it's not we don't know what chloride's out there. So I call it the hidden ninja, okay? The plant still needs chloride, but you have to watch out that it gets taken up in too much excess, okay? Here, this chloride, this sulfur here, was doing the same thing. Big peak in sulfur was suppressing the phosphorus. Once we pulled the sulfur down, we open up the door for the phosphorus, okay? This same thing can happen with chloride. This particular grow, these are both from the same grow, they tend to keep the chlorides low. This is more of a living soil, but in pots. Okay? Here's another example how you can use sap analysis. If you're doing pots, or if you're doing anything with hydroponics, you have a nutrient feed in, you have uptake by the plant, and you have a drain. If you use the data from your feed in, your uptake monitoring with your sap and your drain, you use the three pieces of these data. This is actually 4 samples, 1, 2, 3, 4. You use that together to make sure that the plants are fully satisfied, and then you monitor your drain, which you have to back calculate and add back in the amount of moisture that was taken up by the plant. Okay, so if you've got a 20% drain, 80% of the moisture was taken up by the plant or evaporated off. So you've got to add that back in to the ppm down here. Okay, now you know exactly how much nutrient is flowing through that the plant isn't taking up. Okay, so you can use this to dial in this feed back here to make sure that the plant is still satisfied and you're not wasting nutrients down into the disposal. Okay? This is exactly what we were talking about. Here's a sap analysis. Here's the feed formula. Here's the drain. And this is why you have to add in the moisture back in, because you can see that the EC is actually higher in the drain than going in, because it concentrates in the root zone if you don't add the moisture back in, right? Okay. Nutrient uptake for optimized yield. Nutrient uptake for optimized boutique terroir, okay? We talk about this with my wine growers. It's not always about how many pounds of grape we produce. It's the mouth appeal, it's the smokability, it's the flavor. So we're not always growing to figure, we want to get pounds, but if you're growing pounds of crap, it's not going to do you any good. So quality, every time somebody opens a jar out here, every one of us is putting it to our nose, right? We want to have nose appeal, and it better follow up with a good taste, otherwise it's no good to us. So these are all things that this is where SAP analysis is taking us, is that we're now tying nutritional profiling into analysis for terpenes and THCAs and yield performance. And this is where we can project these things out. Nutrient uptake to improve integrated pest management. This will be hotly contested. We have anecdotal evidence, okay, in other species that as you move bricks higher, pests will not feed on that plant if they can go to another plant that is more susceptible. It becomes less digestible to them, so they will go someplace else. Okay, it's not that it's not consumable. It's that it's sort of like wolves don't always, that they pick on the weak of the pack. Okay, we have an entire organic leafy green company, one of the biggest in the country, Baraga Fresh, out west, that is using this through us, and in 2 years they have almost eliminated aphids on all of their cauliflower and broccoli and cabbages by pushing their bricks higher, the levels higher, and they have more nutrient dense leafy greens. Okay, but they've been able to reduce this and reduce their concerns in organic leafy greens from that. Where are some of the other places we're going with SAP analysis? We already do heavy metal analysis because we live in a state in Michigan where heavy metal analysis in finished flower is critical. California, we service all the states in the United States and Canada. So test the heavy metal uptake in the sap. If we're getting it there, it's going to end up in the flower. So let's do some prevention. Let's stop it and figure out where we're getting it from. Carbon nitrogen ratio. This is a new one that's going to come on this year, where we're now going to be able to take a look at total carbon along with the total nitrogen. There's some work coming out of Israel where they have monitored the carbon uptake relative to nitrogen uptake. And the initial look at this is saying that when you have excessive nitrogen uptake, it inhibits the cannabis's ability to take up carbon and to form carbon molecules. Okay? So, we monitor, as growers, nitrogen all the time. And if something looks pale, we put more nitrogen there. I will tell you, we see a lot of excess nitrogen. If we do that, we inhibit the carbon. We may be, because we don't have the data on it yet. But that lack of carbon may be inhibiting our ability to form sugars. And a lot of our terpenoids are carbon-based molecules, and terpenes are carbon-based molecules. So, we may be kicking ourselves in the ass, okay? Don't have the data on this yet, but we're going to start looking at it this year, okay? I think there's also some place here with regenerative agriculture where we can start looking at the fact that, hey, if we're trying to build more carbon in the soil, what's the carbon-nitrogen ratio in the plant and in the sap? How's that going to be beneficial? Looking at THCA, CBDA, CBGA, and terpene profiles in the sap as they're being manufactured in the leaf and transferred up into the flowers, those types of things, and seeing how that profiles with nutrient balancing in the plant. Can we optimize for these things? Tactics. This is some data I was crunching here over the last couple of weeks. This is all from the last 2 years. Last year when I put this data up there, I couldn't make heads or tails of looking at outdoor versus greenhouse versus CEA, guys. There was so much noise in the data, the standard deviation was all over the place. So I took a little bit different look at it this year. This is just the mobile nutrients, okay? And what I've done here is I've looked at the mobile nutrients, and what you're seeing here is in this data is the first and third quatriles of all these nutrients for these types of grows in the data that we have for all the grows that we've scaled out as either above average to exceptional. Okay, the ones that have scaled out lower, we've pulled out of this data. So this gets us going into developing target ranges for where these nutrients should be for this type of growing style. Okay, so this is a management target range for the growing style, for an outdoor grow, for a greenhouse with soil, for CEA. These are where you probably should be looking at, okay? I don't know that it's necessarily great because I think there's more influence by the strains than there is by the management style, but there are some differences here. There's also an indication from what I could see in the data that if you look at the balance within the cations between the three growth styles, those balances are pretty much the same. I mean, if chloride is going to be between 77 and 73%, no matter what growing style is, well then I know that by balance it's probably going to be about 77 to 73%. Doesn't mean what concentration, it just means by balance it's going to be in that range. sulfur 15 to 14%, phosphorus 7 to 12. Now that's a pretty big swing, with outdoor having a big shift there. Outdoor is probably where we have the biggest problem with uptake of phosphorus, just outdoor grows. Cations, pretty much the same, but look here, indoor grows don't get the calcium uptake. The balance in indoor grows is not the same for calcium as the two outdoor or indoor with soils, greenhouses. So something's going on there. Which shifts then to more magnesium on the indoor grows. Okay? And then we got nitrogen uptake, and then what I've started to play around with here is nitrogen to phosphorus, nitrogen to potassium, and nitrogen to calcium ratios, which, there's quite a big difference in the nitrogen to phosphorus, but we saw the big problem with phosphorus in outdoor grows. Other than that, I don't see a whole lot of difference across that line. Thank you. Let me see if we can get through, slam through a couple more of these. These are some major pieces that I did last year. These are the examples of differences between varieties. So this is some mega data trends across all strains. You can see the difference between chloride and sulfur, phosphorus, nitrogen, potassium, between veg all the way out to late flower. And just how we, the excesses that can be built up. And you see that big drop, usually in sulfur in early flower, but you see magnesium really falls off as flower develops. We're having a problem with that, but it's usually because we're getting a huge excess. Potassium tends to stay continue to build up. Don't mind the sodium being so tall, that's just because it's a relatively small amount, but it tends to build up in there. Chloride falls off as the grow continues to go. As far as being in excess, it does not mean that it falls off in concentration. Here again, this is blueberry muffin. This is new versus old in veg, early flower, mid flower, late flower, and it kind of shows you some of the relationships in some of these. And probably with 5 minutes, I can't go into all of that, but you'll get a copy of this. And if you have a big interest in blueberry muffin, feel free to give me a call. Here's early flower, late flower on wedding crasher. Wedding crasher is one that you cannot feed heavy; it will burn. But it does have an issue with some nutrients here. Here's the difference data. You can see the different nutrient profiles between fudge sickle, potato runts, apple fritter, wedding cake, and ICC. They do not feed the same. You can see the different differences between excesses and deficiencies across these. And then this comes from a paper. The paper is cited up here. It's kind of small. This is going into concepts of applying higher light, PPFD, and temperatures, and how it affects intercellular CO2, transpiration rates, water efficiency, dark respiration. Take into account dark respiration, particularly for your calcium. Okay? A lot of times your calcium, particularly if you're growing indoors or in greenhouses, focus on your root pressure. Okay, root pressure in dark periods will contribute mightily to your uptake of calcium. Okay, because you're now not getting all the back pressure on the sieve cells from the rapid movement in the phloem. You've got a lot of pressure going on with uptake and transpiration, a lot of back pressure in sieve cells. You can actually get a negative on xylem. So in the dark period, when that calms down, you can get a lot of uptake, particularly in the buds and stuff, in dark periods if you get good positive root pressure in your dark periods. So this is some of the stuff that we've been trying to work with folks and correlating better uptakes, and how do we tie this in with PPFD. That's my contact information and the phone number at the lab. Yes, sir.
I think I got two, but I'm wondering how you measuring root pressure for one, and then for two, I wanted to see if you could circle back at all as far as the bricks, raising bricks for IPM management, and more specifically like septoria, which maybe you see in Michigan. Have you ever helped farmers push their bricks up to overcome fungal pathogens?
You won't be able to overcome septoria with bricks because of the fungal
maybe
concept.
ahead of time. Maybe if you get your nutrients right from the start, preventing it from happening.
You have to focus on particular nutrient uptake there. Okay, here with most of my grows with septoria, what we're focusing there on is particularly getting your copper and selenium and silica up, and zinc up early. Okay, a lot of times my outdoor grows don't tend to focus on their sap and plant nutrition until they transfer out to the field. So where we should be focusing on making sure that nutrient uptake is ideal is when they still got them in the greenhouse or in a lot in a veg state, and so that we get them out there just right. Okay. I think that's where we got to start with the micronutrients. Micronutrients are terribly underrepresented, okay? And then we're typically putting them out outdoors or in pots, okay? So you've got a couple different issues there. Native soils they don't pay attention to nutrition really well in native soils. Pots, not always the best soil in pots. You know, they bought whatever they could to fill out a gazillion pots, and it's not always very good soil. Then you've got management issues. There's a lot of inter-row growth of weeds. Crabgrass is particularly bad in Michigan, and it gets septoria really bad. Clover, not as bad, but clover causes other problems. I highly recommend a multi-species ground cover between rows. We also have a product that is produced by ISP called Sci-Fight. It's a silicate phosphite that they're using on tar spot in corn. It has been very successful. I highly recommend that you spray that not only early on cannabis, but spray the inner rows as well. Keep the septoria under control as much as possible. Then, how you manage the inner crop is important. The worst case I saw last year was from a grow that decided that they didn't have enough field staff, so they hired a landscaping crew to come in and they weed whipped all of the vegetation in the rows, and the amount of vegetative matter that went up on the cannabis was tremendous, and then septoria just went through everything. There are also varieties that are highly susceptible to septoria, and some that are very resistant to septoria. If you've got a variety that's susceptible to septoria, get it out. It's not going to do you any good anyhow. You're going to struggle with getting it, and the amount of labor you're going to put in thinking that you should defoliate all the crispy leaves, you're probably going to lose money on it anyhow.
For sure, thank you.
Yeah. You got it. I think she's got it.
One more.
Yes, sir. Yeah. $30°C. Yeah. So your best for your dark respiration, you're going to get your best dark respiration between this 25, and 30. 30 is being the highest in this study. Okay, but in that area, that dark respiration is going to give you the best between 25 and 30 degrees Celsius. This study up here is the photosynthetic response of cannabis sativa L to variations in photosynthetic photon flux densities, temperature, and CO2 conditions. And this was in Molecular Biological Plants 14 in 2008. And they did a lot of this work was with, what's the company that makes that instrument that Mike? Lycor. Yeah, they use the Lycor instrument, which it basically clamps onto a singular leaf to measure some of these things. Okay. That is, yeah. No. This is temperature in the room. Yes. Yeah. That's it. My daughter's telling me I gotta get off the stage.
Thank you. And next at 3:30 is going to be your SAT testing workshop. So that's where we're going to go out in the field and actually physically pull samples, get them in the bag, get them to the laboratory. Seeing that process is definitely makes you a little bit more confident in gathering your samples up and getting them to the laboratory, and I highly encourage that. So definitely check out the SAT testing workshop a little bit here. We're going to take a break for a little while, and then starting at 2:30 is going to be Izzy with Sustainable Village, understanding your soil's blueprint of its moisture. So understanding your soil through its moisture levels. So we're going to be covering a lot of different things as far as soil moisture level goes at 2:30. So come on back here. Thank you very much, guys.
Yeah.